All right, today we're going to be learning about time zones, what they are, and why they exist, and how to figure them out. So, we've all been watching TV and heard something say, this show premieres Tuesday, 7 Central, right? So like you hear like maybe 8 Eastern, 7 Central, and you're like, what does that mean, right? So what this really means is that we are on the East Coast, right? So we're New York. Let me get a globe. So we are on the East Coast here, right? And Central Time is actually in more the inland area, right? And then we have something called Mountain Time, which you probably don't hear much about, but there's also Pacific Time, which you may hear about. So I've been on Instagram before and I heard like celebrities say like, oh, I'm gonna be live streaming at 8 Pacific Time. And in my head, I'm like, oh no, I'm on the East Coast. So that means it's gonna be 11 for me. But the idea is that when you hear these previews, right? 8 Eastern, 7 Central, doesn't matter where you are in the United States, you're all going to be watching that show at the same time, right? So it's not like it's going on the TV at a different time in different places. Everywhere across the United States, whether you're in New York or you're in California, you'll be watching that TV show at the same time. It's just that your clock, the man-made thing, right? So the clock is man-made, but time is not, right? So the clock, the number on the clock is just going to be different. You're just going to be seeing at the same time. And there's a reason for this, okay? There's a reason for this. So why do we have different time zones? Here's the Eastern, Central, Mountain, and Pacific, okay? So why do we have these different time zones? So I'm going to show you a video on sunrise, but really the question is, where does the sun rise, right? So if this was sunrise, I would have to be on the East Coast looking east because the sun is rising somewhere towards the east at all times. So this is the East Coast and you'd have to be looking east, right? So that means if you're the sun in this video, right? So you're over there, the East Coast is going to be rotating towards you, and at this point, boom, I'm in New York, I can see you, right? So you're rising through my sky. As the Earth continues to turn, you get higher and higher in the sky until New York is kind of facing you, and then you're going to get lower and lower in the sky, right? But the key is that in New York over here, although New York can see you when it's right here, California can't. So in New York, when our sun rises, it's still dark in California. So the Earth continues to turn, and 3 hours after our sunrise, the sun rises in California, okay? So why different times on our clock? Well, let's take a look. So if we wanted to watch the sunrise from outer space happen really, really fast, this is what it would look like. Right? So the East Coast sees the sunrise first, and the West Coast sees the sunrise last. All right? So what if everyone had the same time? What if everyone followed the East Coast clock? Everywhere on Earth, it was, and right now it's 8:22. So what if that was the case? So let's imagine sunrise. So the sunrise is usually around 6 a.m. in New York, right? So what time would it rise in central area, right? So around the central area, like Illinois right here, the sun would rise at 7 a.m. Still not too crazy, right? But again, if everyone had the same time on their clock, the sun would rise around 8 a.m. in Colorado. So that means that if kids start school at 7:30 a.m., the sun doesn't rise until 8 a.m., so they'd be out at the bus stops or walking to school in the complete dark. People would be driving to work in the complete dark, which is pretty dangerous. And now imagine this. In California, sunrise would be at 9 a.m. 9 a.m. So some kids would be in school in third period and the sun would just start rising. That'd be pretty brutal. And then in Hawaii, the sun would rise at 11 a.m. So the point is, we make the times different across the longitude or across east to west because we want the sun to rise everywhere just about 6 a.m. That's the goal. have the sun rise around 6 a.m. for everybody. No one wants the sun to rise at 12 noon when they're halfway through their day and the sun is just coming up. That would be brutal. That would be brutal, okay? So, that's why we have time zones, okay? So if it's 6 p.m. in New York, that means it's 5 p.m. in Central Time, 4 p.m. in Mountain Time, and 3 p.m. in Pacific Time, all right? So that makes it so the sun rises everywhere. Well, not everywhere, but it makes the sun rise at specific times, around 6 a.m. everywhere, okay? So what you need to be able to do for this is if you're given this time zone chart, you have to understand that every time zone we leap towards the right, it's like a number line, right? So if this is 3, the next one to the right is 4, 5, 6, right? So we're just going to count over towards the right. It is that simple. Same thing with the eastern side. So if we're at 6 p.m. here and they asked us what time is it in California, we were just like, okay, it's 6 here, so 1 less is 5, 1 less is 4, 1 less is 3. So this is where a little bit of math comes in. How many time zones are there? So how many time zones are there? Well, since humans created the clock, right, and we decided to put 24 hours in a day, there are 24 time zones. 24 hours in a day, 24 time zones. And here's another thing that we have to understand. How many degrees does the Earth rotate every day? So in one day, the Earth goes around, right? So if we think about that, going around is a circular motion, so that's going to be 360 degrees, all right? Stay with me here, stay with me. Let me show you the board for a sec. So the Earth rotates 360 degrees, right? And that takes 24 hours, or 1 day. So we need to figure out how many degrees does the Earth rotate per hour. Okay, so if the Earth rotates 360 degrees in 24 hours, how many degrees does the Earth rotate every hour? If you put this into a calculator, it equals exactly 15 degrees every hour. So that means that if the Earth rotates 15 degrees every hour, to rotate all the way around takes 24 hours, right? 360 degrees around takes 24 hours. That means every 1 hour, the Earth rotates 15 degrees, just a little bit, right? But this has further implications, all right? Further implications. So for seasons, latitude matters a lot. So let me just remind you of what that means. We're almost done here. So for seasons, latitude matters a lot. So what does that mean? So based on the equator, this is latitude, right? If you're north of this, the further north you get, the colder it gets. And if you're south of this, the further south you get, the colder it gets. So that's seasons. But for time zones, we care about the longitude lines. So these are called longitude lines. The way I like to remember that is that they're all equally long. They go from the North Pole to the South Pole. They're all the same length. So that's how I remember longitude. And the idea is that as we rotate, you'll be seeing new longitude lines if you are the sun. So the sun rises first in New York, then it rises in Illinois, then it rises in Colorado, then it rises in California. And those all happen an hour apart. So every 15 degrees of longitude, 75 degrees west, 90 degrees west, 105 degrees west, 120 degrees west. All these lines of longitude are separating our time zones, generally, just like about. You'll see that they're not perfect lines, these different time zones, and that's because we have states, we have counties in these states, and these different counties have different rules about how they want to be in some time zones, don't want to be in other ones, depending on how close they are to a city, or if there's like a stream or river splitting them. So that's complicated. But the main idea is that every 15 degrees we have, or every 15 degrees of longitude, we have a different time zone. Okay, so they'll ask you a question like this. Let's take it back. So if it's 10 a.m. on the west side, on the west coast, or the Pacific time, what time is it in New York? You just go, okay, this is 10 a.m. I count 15 degrees, so 120 degrees to 105 degrees. This is going to be 15 degrees, another 15 degrees, another 15 degrees. 10 a.m., 11 a.m., 12 noon, 1 p.m. Okay? Cool.